Thank everybody for joining us for another ChemPoint MOLYKOTE webinar. Today we'll be going through the electrical performance protection with lubrication. We're going to have Brendan Schreiber, who is a application specialist with DuPont MOLYKOTE. He'll be running through this webinar for us. Take it away.
All right, thanks, Kaku. Hi, everybody. As Kaku mentioned, I'm Brendan Schreiber, an application engineer for the MOLYKOTE brand. In this presentation, we're going to highlight the topic of electrical performance and protection with MOLYKOTE products. Okay, so let's take a quick look at our agenda. In our first section, we'll start off by really understanding the importance of electrical lubrication. Then we can talk about both the electrical protection and performance we can gain from lubricants. And then we'll unpack a few case studies where MOLYKOTE products have helped prevent failure in electrical applications. Okay, section 1, the importance of electrical lubrication. So when we talk about electrical lubrication, there are several common electrical failures we are looking to prevent, and they really can be broken down into two categories. To start, as you can see, we have several green tiles that represent failures falling under the performance category. Common failures in electrical performance include pin-to-pin crosstalk, where signals can jump across pins in a connector. We also have the more known short circuit and electrical arcing. And lastly, we have a high contact resistance that can form at the electrical connection. On the other hand, we have the purple tiles representing failures falling under the electrical protection category. As these are more tangible forms of failure, these include moisture ingress, corrosion, and deterioration or fatigue of a connection. In a bit, we'll unpack these topics a bit further and talk about preventing these failures with the MOLYKOTE product line. So what is the potential impact of a lubricant? Sticking with these two categories of performance and protection, lubricants can affect performance by preventing electrical pin-to-pin crosstalk and electrical arcing with their strong insulating properties. Along with that, they can create a tribological film to prevent wear of moving pieces, such as switches and plugs. In terms of electrical protection, lubricants can do a great job of restricting moisture ingress. They can also have corrosion additives to protect connections and switches from corroding. And lastly, but not least, lubricants can do a great job of protecting polymers and seals from deterioration. This helps maintain the integrity of plugs and seals for performance and serviceability. Okay, now we're on to section 2. Here we can build a better understanding of lubricants' ability to actually protect the electrical applications. The first and largest topic is water and moisture ingress. This is because so many electrical connections and switches are encapsulated by seals to protect them from the outside environment. The common cause of failure is seals deteriorating or tearing to allow water ingress. This unfortunately leads to galvanic and crevice corrosion, short circuiting and arcing, or failure to transmit signals in your electrical application. The ingress of water can really be the demise of an electrical switch or connection. Fortunately, lubricants can help prevent these failure modes. Primarily, applying a lubricant can help extend the life of the elastomer seals. They help prevent rips, tears, swelling, and embrittlement during service. Additionally, lubricants can support a seal's ingress protection, or as they call it, IP rating. This added layer of protection ultimately helps prevent corrosion and poor signal transmissions. Now, in order to achieve the benefits of lubricating plugs and seals, it is important to not overlook compatibility. When we say compatibility, we're referring to the lubricant's compatibility with various plastics and elastomers, or in the case of electrical applications, this can include seals, plugs, switches, cases, and housings. Incorrect lubricant selection can shrink or swell a material, leading to deterioration and embrittlement. This ultimately jeopardizes the serviceability of the polymer and shortens its lifespan. When selecting a lubricant for your application, a rule of thumb to start with is likes don't like likes. So for example, this means you should generally avoid using a silicone lubricant on a silicone elastomer, as it will swell and weaken the elastomer. When it comes time to make a selection, it is important to know the material of your plug and seal. MOLYKOTE has a plethora of compatibility data on most elastomer lubricant combinations to help make the correct lubricant selection for your application. Another important benefit of lubricants in these electrical applications is to prevent corrosion. Now, corrosion can appear in several different forms. Some of the more applicable versions are galvanic corrosion, crevice corrosion, and fretting. To touch on galvanic corrosion, it occurs when moisture is in the presence of two dissimilar metals. So as shown in the figure on the right, the electrolyte decays the anode, damaging the electrical contact and then ultimately increasing the electrical resistance. This is important in many connections where the wire and the connector are dissimilar metals. Another important type of corrosion to address is crevice corrosion. As the name suggests, crevice corrosion occurs in between small crevices where oxygen cannot freely circulate between metal pieces in a contact. This is commonly found on the seals of electrical cases, trays, and pass-throughs. When the corrosion forms, it jeopardizes the serviceability and sealing performance of the assembly. Fortunately, lubricants can help mitigate the formation of corrosion. Lubricants with high tack and great water washout resistance create a strong physical barrier to prevent exposure to moisture and other environmental factors. This ensures plugs and switches perform as intended for a longer time and protect the serviceability of the assemblies. The third form of corrosion we mentioned on the previous slide was fretting corrosion. Fretting corrosion deserves to be separated from galvanic and crevice, as it forms through a different process. By definition, fretting corrosion is vibration-induced wear, rather than corrosion due to environmental exposure. Fretting corrosion can be found in electrical switches and connectors where there are small oscillatory movements at the interface of two metals. This continuous oscillation breaks down the oxide layer through the metal surface and accumulates damage and debris. This typically leads to switch and connector seizure, making them unserviceable and increasing contact resistance and degrading performance. As shown in the visual below, lubricants can help mitigate fretting corrosion by creating a tribological film to physically prevent debris formation and damage to the metal-on-metal contact. Now that we've built a better understanding of a lubricant's ability to protect electrical application, let's move on to section 3 and discuss electrical performance with lubricants. So to kick this off, why are we tying the knot between a lubricant and electrical performance? Well, there are 3 topics I want to touch on with you today that are all affected by the presence of a lubricant. These include pin-to-pin crosstalk, where it is important to have clear electrical signals transferred without interference, prevention of short-circuiting and electrical arcing that can be detrimental to an electrical system, and the protection of an electrical connection's contact resistance. MOLYKOTE products have a hand in each of these performance metrics, helping electrical systems perform as they were originally intended. Okay, so let's dive into the details of electrical crosstalk. Crosstalk is the unwanted transfer of a signal from one circuit to another adjacent one, causing interference and degraded performance. So for example, let's take a look at the visuals on the right. Let's say we have a multi-pin connector where there are 2 unique electrical signals transferred through adjacent pins. If there's an interference between these 2 signals, they can become additive and affect the final signal transferring through the connection. This is where we introduce products such as MOLYKOTE silicone compounds. These products have an inherently low dielectric constant and dissipation factor, which means they greatly resist the transfer and storage of electrical energy. When introducing a MOLYKOTE compound to a multi-pin connector, the product acts as an electrical insulator and prevents crosstalk between these adjacent pins. It effectively isolates and protects the electrical signal through each individual pin. Another performance metric that is more tangible relates to short circuit and electrical arcing. To set the stage, short circuits and arcing occur when an electrical charge flows along or jumps to an unintended path of least resistance. This can happen for several reasons, such as a lack of insulating material, water intrusion, and corroded connections. When this is the case, it can lead to a damaged equipment, excessive current flow, and even safety hazards. Fortunately, lubricants with high dielectric strength are great electrical insulators, which can help contain current within the circuit. A great example is with spark plugs. While a lubricant can offer ease of assembly and disassembly, applying an insulating compound also helps prevent corona discharge and electrical arcing to assure a more consistent and reliable performance of your spark plug. So in this section of electrical performance, we have covered 2 cases where the insulating properties of a lubricant can help prevent the unwanted arcing or signal crosstalk. However, you may be thinking, it's great that we can prevent arcing and crosstalk, but I don't want to increase the contact resistance at the actual electrical switch or connection. Well, fortunately, we have an answer for that. While MOLYKOTE silicone compounds are great insulators, they also have a very low surface tension. This helps them minimize the film barrier at the connection point, ultimately minimizing the imposed electrical resistance at the connection. So by establishing that, it's important to address the factors that can increase contact resistance. As shown in the figures on the right, factors such as dirt and debris, corrosion, and lubricants with a significant film thickness can all increase contact resistance. These can all lead to excessive heat, signal degradation, and voltage drops within a system. That's why it's important to use a product like MOLYKOTE 111 or 4 compound to minimize this contact resistance. Now that we've covered how lubricants can impact both protection and performance, I'd like to show a few real-world examples of MOLYKOTE products in electrical applications. In this example, we're going to be talking about an automotive electrical connection, in this case, for a battery electric vehicle. Specifically, the piece serves as a pass-through connection to the inside of an aluminum casing. Now, for this application, the customer was facing several challenges. They needed a dielectric grease that could protect the actual electrical connection made through the pass-through. They also needed a dielectric product that would support insulating a high-voltage electrical connection. It needed to be compatible with each material making up the connector assembly, so that would be the header, the connector itself, and the seal, as shown in the figure on the right. And lastly, the customer wanted a product that would not migrate and support sealing in an environment seen through the life of an automobile. So knowing these were the performance metrics the customer was looking for, our approach was to evaluate several lubricant options based on properties pertaining to these requirements: dielectric strength, polymer compatibility, corrosion protection, water washout, and inevitably cost. So on this slide is a breakdown of several candidates for such an application. When lubricating a sealing application, a great starting point is always going to be MOLYKOTE 111 compound. It offers a wide temperature range, great water resistance, and is compatible with a wide range of plastics and elastomers. However, if we need to move the needle on specific performance metrics, we have other MOLYKOTE products to explore. If we're looking for a compound with a lower temperature range and great dielectric properties, MOLYKOTE 4 compound is a great option. We also have grease options with great dielectric properties, such as G5008. If corrosion protection is an important metric, MOLYKOTE G2113 has excellent adhesion and is great for sealing and protecting from corrosion. And lastly, if you're looking for a product that's best with polymer compatibility, we have PFPE greases such as HP300 that also provide superior resistance to chemicals, solvents, and harsh conditions. So what did we recommend for the automotive pass-through connection? Well, as a polymer compatibility and protecting the electrical connection were the top priority, we elected to recommend G2113. When testing compatibility with the materials making up this connection, G2113 showed great performance on par with HP300, which is a fully fluorinated product known to be the pinnacle of compatibility. Along with that, G2113 showed great dielectric strength, which would help insulate and protect the connection's charge flow. And lastly, G2113 is great at resisting water washout to help support the function of the pass-through seal. Moving to our second case study, here we have an electronics clamshell seal. While a clamshell seal can cross over through many industries, this application was specifically an aluminum automotive battery tray with both EPDM and silicone seals. I mentioned both the EPDM and silicone seals as that will be important later. As you can see in the bottom left picture, we have the aluminum clamshell and its silicone seal that stretches around the perimeter. Then in the photos on the right, there are several PBT breather ports in the aluminum clamshell that have utilized an EPDM seal. Initially, the customer was struggling with moisture ingress and crevice corrosion. They had tried several lubricants and even adhesives, but couldn't pass their standards for material compatibility, crevice corrosion, and assembly and disassembly for this application. Ultimately, the customer needed a lubricant to mitigate the crevice corrosion and allow for easier assembly and disassembly. They also needed a product that was compatible with both the silicone seal around the clamshell and the EPDM breather seals. So to reach a solution, we performed a sequence of tests to evaluate several MOLYKOTE products against the customer's incumbent materials. To start, elastomer compatibility testing was performed for both the silicone and EPDM elastomers in this application. The customer insisted the product was compatible with each so the seals would not deteriorate over time. Along with that, we developed a crevice corrosion test to run over several weeks in a salt fog chamber. As shown in the figures on the right, we sandwiched an EPDM and silicone elastomer between aluminum panels and coated each with the lubricants to be tested. Upon completing the tests, we were able to evaluate the crevice corrosion prevention for each material. With these two tests, it was found that MOLYKOTE's G2113 candidate for this application. It displayed great compatibility with both EPDM and the silicone elastomers, while also providing excellent protection from crevice corrosion and resisting water spray off to ensure it stays adhered to the application. For our last case study, we take a look at power distribution. Here, the customer's application was a bypass switch. These are devices to transfer electrical loads from a preferred power source to an alternate source. While this is a specific application, fundamentally, it is a high voltage electrical switch that needs friction and wear protection without jeopardizing the electrical contact resistance. As the customer discussed their application, they needed a lubricant that could provide lubrication in both static and dynamic conditions of the bypass switch, which had a very high voltage and current. The lubricant needed to perform between -40°C and 55 degrees Celsius, and they needed to prevent the wear of silver plating on the mating parts of the bypass switch. During their initial trials with an incumbent material, they were struggling with the lubricant breaking down, darkening, and increasing the contact resistance just a few weeks into service. So they were looking to greatly improve this life cycle of their switch. To reach a solution for this application, testing was performed on several MOLYKOTE products that would be a good candidate for such an application. It was found that HP300 was the best product for this application as it shows excellent self-oxidation resistance on the surface of a silver-plated aluminum alloy. Additionally, it was found that HP300 maintained the low contact resistance in motion and static conditions of the contact switch. This led to the customer using MOLYKOTE HP300 and seeing significant extension in the service life of their lubricated bypass switch.